Good afternoon. My name is Valen Morales, and today it is my distinct honor to present to you about the Global Positioning System, commonly abbreviated to GPS. All throughout history, thousands have wondered the same questions. Where am I? Why am I here? Where am I going? Now, those questions today are most commonly asked philosophically, but throughout history, those questions were literal. Where am I? Knowing your location was a fundamental challenge throughout history. Unless someone had line of sight to some point of reference, that person was hopelessly lost. Navigation was limited to the sun, moon, and stars, or moss on a tree. Eventually, maps came along, but maps are useless without being able to correlate the map to some visible landmark. As time progressed and countless groundbreaking inventions were made, the technology in determining location lagged behind. Maps became more accurate and radar was invented, but there wasn't a big need for newer technology, and therefore no drive to invent some. A wise man once said, "Necessity is the mother of invention." Well, no one knows necessity better than the United States military. In the 1940s, the United States became embroiled in World War II. As naval battles took center stage, the need to know something's location was never greater. The stars could only tell you what direction you were going, and radar what was close by, so captains still had no idea where they were or where the enemy was. The Navy's first attempt at geopositioning was called the Long Range Navigation System, or LORAN. LORAN was, as all future systems would be, powered by radio waves. In essence, 3 stations of a known location would broadcast a radio wave. Somewhere in between them, the naval vessel would pick up the radio waves. How quickly it picked up the signals would depend on how close it was to that station. The vessel would then convert the 3 time values into distance values based on the speed of light. The distance from one station would create a circle of uncertainty as to where the ship was. The second station would create a second overlapping circle, which looked like a hyperbola, which is why LORAN is referred to as hyperbolic navigation. These 2 circles would create 2 possible locations, so a third station was needed to determine which one. LORAN was groundbreaking, but lacked accuracy, efficiency, and usefulness on land. As the Cold War ramped up, the pressure was on the Navy to invent something better. The concept of satellite navigation in the 1950s was something of a science fiction idea, not something that could be feasible. That all changed, however, in 1957 as the Soviet Union kicked off the space race with Sputnik. The first artificial satellite wondered many, but for 2 researchers at Johns Hopkins University, it posed an interesting mathematical problem. Could they determine the position of the Soviet satellite from Earth? After many hours of listening to the radio, intense mathematical calculations, and using a UNIVAC computer, the pair was able to track the relative position of the satellite. The Navy then asked them to calculate the problem in reverse. Could they figure out a position on Earth based on the position of the satellite? Once this problem was solved, the world of possibility was opened. For the Navy, this was a crucial advancement in the Cold War that paired with their biggest project, submarine-launched ballistic missiles. In order to accurately hit the target, the location of the submarine had to be known. The Navy began developing a new system in earnest, and in 1960 successfully tested the transit system. This system could determine with some accuracy the location of the submarine, which would then be used to calculate the missile trajectory. This system was somewhat inaccurate, but thankfully you don't have to be too accurate with nuclear weapons. As technology improved, accuracy was increased, and in 1978 the first Navstar satellites were launched into space to form the Navstar Global Positioning System. Shortened to GPS, this network is what is in place today, saving you from having to ask directions on your next road trip. GPS has applications in many different fields, in military or commercial or on your next road trip. GPS works by answering 4 questions. What is the receiver's latitude, longitude, and height? And what is its time difference from the satellite? Each satellite can only answer one question at a time, so 4 satellites must be available for the system to work. GPS functions the same way as LORAN. Radio waves are transmitted from the satellites and picked up by the receiver. Each radio wave has a specific modulation that tells when the signal was sent. All of the satellites have synchronized clocks. However, the clocks move at different speeds than clocks here on Earth because of various environmental factors. When the receiver receives the radio signals, it calculates the time difference between its clock and the satellite's clock. Once that difference is established, the receiver records the time it took to receive the other 3 signals and converts those time values to distance values. Once all 4 values are known, a system of equations can be calculated. The receiver is found where the equations intersect. No matter where a receiver is in the world, the system can pinpoint the receiver's location within a yard or less. GPS was designed for military use, but after a Korean Airlines flight disastrously wandered into Soviet airspace, President Ronald Reagan released GPS to the public. Since 1983, humanity has been able to answer the question of, "Where am I?" thanks to the wonderful work of GPS.